we are going to keep the ball rolling in just a moment. I'm going to invite my next guest up on the stage, and we're going to have a presentation talking all about his inspiring work. Apoorv Sinha is the co-founder and CEO of Carbon Upcycling, which is a leading carbon capture and utilization company that is building a world where CO2 is a resource for a sustainable future. Get excited. Please welcome Apoorv.
Hi, everyone. My name is Apoorv Sinha, and I serve as the CEO and co-founder of Carbon Upcycling. It's a pleasure to be here. Thank you, Graham, Michelle, Holly, and the whole EDU team for hosting us. I wanted to start out by talking about what Carbon Upcycling is about. We are a carbon-to-value company focused on becoming the most impactful carbon utilization company of the decade. And just given the timing of the conference, I wanted to start with a picture of New York. This is where Climate Week was held last week. We were present and participated in a whole bunch of different events focused on carbon and reusing and sequestering carbon away from our biosphere. And what's interesting about that is, if you look at the current trajectory of what we need to do to advance economies all around the world, look at urbanization and development of the global south, we'll be building the equivalent of New York every month between now and 2060. And this presents a massive challenge in our evolution towards a green economy and a green future. And the reason for this is cement cannot be made green the same way that electric vehicles can make transportation green. There is a fundamental chemical reason for why there's a lot of emissions associated with making cement in the way that we've been making it for 200 odd years. And primarily it goes back to the fact that essentially cement production is baking limestone at very high temperatures. That means that you have an oven that runs at 14 to 1500 degrees Celsius. That needs fossil fuels in our current kind of condition, requires a lot of fossil fuels to be burned. But then in addition to that, the limestone itself, as it decomposes, emits a lot of carbon. And so for every ton of limestone that you make into what we call Portland cement, which is really the building block of all of modern society around us, we're emitting about 700 to 800 kilos of CO2. Now, the problem with cement production is actually not just a cement problem. All hard-to-abate sectors have an issue with carbon emissions, whether it be steel, fertilizers, petrochemicals. We really need a fundamental way of being able to tackle these emissions and find sinks for the CO2 that is emitted by making all these very useful materials in a scalable manner that fits the scope and scale of the problem at hand. And CCS is a great way of doing it, but our view at Carbon Upcycling is that it can't be the only way. What we've worked on over the last 4.5 years is a technology that allows us to take a whole range of industrial byproducts. These can be slags from the steel industry. These can be coal combustion ashes left behind by decommissioned coal power plants. They can be mineral tailings from EV mining operations. And essentially, we found that we can chemically activate these materials with the presence of CO2 so that they not only act as a sponge for CO2, keeping it away from our breathing air, but they also help create a functional product at the end that can create a blended cement with as much as 2/3 of reduction in carbon footprint compared to the cement that we use today. Now, we've been working with a whole bunch of cement partners. In fact, 3 of the 20 largest cement companies in the Western world are investors in Carbon Upcycling. They're working with us to scale up our technology. But what we get really excited about is this core technology of essentially driving the chemistry that we learned about in middle school and high school, where we're all used to these beakers with fancy colored liquids. We're trying to do all of that chemistry with a solid and a gas. So the idea is that we have these solid powders, such as those slags and the ashes that I talked about, or the mineral tailings, and we chemically activate them so that they can take the CO2 directly from a flue stack, add an industrial point source emission, and essentially embed that into the matrix of the solid powder. And this, as simplistic as this looks, is fundamentally transformational, because this allows not just cement companies, but in our view, heavy industry writ large, come up with a meaningful way to decarbonize even where carbon capture and storage underground is not a viable option. So where are we with this? Obviously, the infographic could mean that we're still at a benchtop level, and we're not. What we've been doing a lot over the last 4.5 years is scaling up our technology to where we've already got about 3,000 tons of low-carbon cementitious product into the Calgary marketplace. We've been able to get sidewalks, home foundations, and even started working with Department of Transportation at the state level in the US to show that not only are we producing a low-carbon material in the lab, but we're actually producing a material that these people can use in projects where there's road traffic, human traffic, and people living. And this is really important because there's this whole saying about you have to build things and people will come. Our experience in heavy industry is that is almost never the case. You have to build things with the end user's experience in mind, and you have to come up with something that is not just functionally equivalent or superior to what people have gotten used to using, but you also have to come up with something that they can afford. Because as much as we all talk about this concept of green premium, our experience has been that this is not a scalable way, at least in the policy dynamics that we see around the world today, to create a scalable, meaningful solution that can drive our path towards net zero over the next 25 to 30 years. Because we've been able to do all this scale-up work thus far, we've been able to convince one of the largest cement producers in the world, CRH. One of the running jokes of CRH is it's one of the biggest companies that no one's ever heard of. They have over 50,000 employees around the world. They operate in over 48 different countries, and they invested in Carbon Upcycling as a Calgary-based company about 2.5 years ago out of their ventures fund, and they have now committed to building a plant with us where we'll have a full-scale integrated carbon-to-value plant integrated with an operating cement plant. And not just any cement plant, it is in fact the largest cement plant in Canada and one of the largest in the world. And we'll be able to show here that our technology can plug right into an existing operating plant with no extra handling of raw materials and help them create a cost-effective, low-carbon material that they can provide to their customers without them having to change their practices at a construction site or over at a ready-mix site somewhere in the interim value chain. The reason that they're excited about this is because the green premium is really important. And what we've already shown with our project in Calgary is that we've already been able to get over the threshold of the price of cement in the North American market. Right now, in New York, I made this joke, and I think Calgary is getting there as well. If you were to have a dinner for two in Calgary, that's probably going to be more expensive than buying a metric ton of cement. That was definitely the case in New York. It's more and more becoming the case in Calgary. And when you're dealing with such a highly commoditized product, it is really, really important that the solution you come up with has a credible and believable trajectory to getting to cost parity. And that has been a huge amount of our work with our scale-up. We haven't just been scaling up the technology to work out the scientific and the technical chinks, but also to figure out how can we make this as cost-effective as possible so that builders that are working on affordable homes, companies that are working on mega infrastructure projects, or as we've seen in Calgary, mega infrastructure projects by the cities and at the state level or federal level can also start incorporating green products without having to worry about cost escalation on a larger project scale. And so once we have the Mississauga project running in the second half of next year, we'll be able to show that we'll be within touching distance of the cost of producing cement or the cost of goods sold for making cement at least in the Western world. And over the next couple of years, our target is to get this to be cost equivalent in the global south as well. Because ultimately, our view is that of all of that New York that's going to be built between now and 2060, most of these are not going to be built in the States. They're not going to be built in Canada. They're going to be built in West Africa. They're going to be built in Southeast Asia. And in these countries, margins are razor thin, labor is cheap, and if the technologies that we create today to create the foundation of the 21st century net zero evolution do not help meet the market where it stands, we run a massive risk of having a lot of this be undone if political cycles and policy ends up going the other way. So with all this said, I did want to say that carbon upcycling right now is a cement decarbonization play. We're working with these major cement companies primarily because we know that they have a big problem, and we know we can solve this problem at a cost kind of dynamic that is palatable to them. But that is by no means where we end this. For many of you that might have read John Doerr's recent book, there's this whole emphasis on like this napkin plan and how we're going to scale up everything we do, whether it's in food or climate or sustainability or social entrepreneurship. How do we scale all of this to have impact in the millions and billions of tons, millions and tons of people, millions and billions of people affected. And so with that in mind, when we went back to the drawing board earlier this summer as Carbon Upcycling's kind of executive team, we realized that cement for us is really just the first sphere of theater. You know, this is where we need to prove that we can scale up our technology, we can work with heavy industry, and we can help work within the bounds of all the operational constraints that they work with. But that is only the beginning. For us to really have the gigaton level impact that we want to have between now and 2050, we need to partner not just with cement, but we need to partner with steel, with petrochemicals. We need to partner with fertilizer production companies, companies that are producing almost 60 to 70% of emissions in these industrial footprints around the world. And we need to use that core technology with those little rocks that you saw a few slides ago. We need to tailor that technology to help them solve the problems they deal with today. And our view is that as much as there's this massive focus on the information age today, on artificial intelligence and all the work that is unlocking incredible potential for humanity over the next 20 to 30 years, there is still a reason for us to look back at everything that builds what goes around an information age. And that is all built with hard earth, with steel, with metals, and it's built by people that need food and need fertilizers. And so if we can be a credible, scalable partner for industry across the world, we believe that we can come up with a way of increasing the GDP of heavy industry, which has really been receding ever since the 1700s, and bring that back to being a key lever to help us decarbonize rather than one of our major pain points as it is today. And so as I wrap up, I'll just say that as I look at kind of the second horizon of where carbon upcycling intends to be in 2030, 2035, you know, we talk a lot internally about wanting to be the most impactful carbon to value company of this decade. And really when we say this decade, we mean the next 5 years, because that's really going to determine, in our view, the trajectory of where we go beyond that. But looking into the 2030s, we want to have not just cement companies working with us, we want other heavy industry engaging with us in a way to decarbonize in areas where carbon capture and storage underground, places like Japan, Turkey, Greece, where these kind of things are simply not a viable option because of either policy or geological reasons, for them to look at ex-situ mineralization of sequestering that carbon into rocks and doing it in a way that doesn't take tens and hundreds of years, as Mother Nature has it do, but instead take a few hours in these kind of built-for-purpose systems such that we can really drive the impact that we want and drive ourselves as a whole towards a carbon-neutral future. So with that, I'll just finish and say that we are around for the rest of the afternoon. And for anyone who's interested in how we're looking at decarbonization or some of the conversations that we've been a part of, even if we're not kind of the sole participant in some of these dialogues, we'd be happy to chat about that and yeah, happy to have that conversation. So thank you so much, and I look forward to the discussion.